All right, so far we've talked about the location of our peaks and then how many unique peaks we're going to get. And so what we saw is that some hydrogens are chemically equivalent, and so they fit under the same peak. And so this area under the peak in our NMR spectra corresponds to how many hydrogens that's representing, right? So the area under the peak again corresponds to the number of chemically equivalent protons. Generally, these will be given as a ratio. We'll see what I mean by that in a minute. And you might have to use a ruler to measure this stuff. So it depends kind of what NMR spectra you're looking at. We'll take a look at an example down below, right? So here's one way we can do integration, and it's through these kinds of red lines. And so what you want to do is you want to measure the red lines, the height of these integration peaks, and then find a ratio, right? This one's approximately kind of like 2 blocks. We can just call that 1. This one's also 2 blocks, so that's kind of like 1. And this one's like 3 blocks, which is 1.5 of 2 blocks, right? So it's kind of in a 1 to 1 to 1.5 type of ratio. And so in this case, right, you can't have half a proton. And so anytime you kind of have a decimal, you want to go ahead and round or multiply both things to not have a decimal, right? So this is 1.5. We can multiply that by 2 to make it 3. So this is really a 2 to 2 to 3 type of ratio, right? This corresponds to 2 H's or more, 2 H's and 3 H's, right? So it could be 2, 2, 3. It could be 4, 4, 6. It could be 6, 6, 9, something like that. And again, same thing that you kind of want to measure from the bottom of the peak. This is approximately like 1 square. This one over here is approximately 6. So that's a 1 to 6 ratio, right? So that could correspond to 1 hydrogen and 6 hydrogens, or 2 and 12, or 3 and 18, that kind of thing. So that's one way you might see it done. Another way is they might just straight up tell you. They might say that, you know, this is 1H, this is 2H, that kind of thing. And then finally, the other way you'll see it is they might have some kind of number right here, which corresponds to the area under the peak. And so you just want to find the lowest number, divide all the numbers by the lowest number to get some kind of ratio, and then work from there. So in this case, we've already seen the spectra, right? This is 1 chloropropane over here, and then this is 2 chloropropane right here. And it's exactly what we'd expect, right? We have a peak all the way to the left that corresponds to 2 hydrogens, a peak somewhere in the middle that corresponds to 2 hydrogens, and then a peak over to the right that corresponds to 3 hydrogens. And then same thing for this one. We have a peak over to the left that corresponds to 1 hydrogen, and then a peak all the way to the right that corresponds to 6 different hydrogens, right? So be able to look at an NMR spectra and figure out how many protons each peak represents.